Welcome back to the Modern React 19 series. In the previous chapter, we learned how React handles events and forms. Now we are going to move into one of the most important concepts in modern React, hooks and side effects. So we will start with use state, which we have already been using throughout our application, and then we will spend most of this chapter understanding use effect. So we talk about dependency arrays, cleanup function, browser APIs, timers, asynchronous data fetching. But more important, I want to help you build the right mental model for use effect, because one of the most common mistake developers make is treating use effect simply as a place where they put code that should run after rendering. That's not really the best way to think about it. A better way to think about an effect is we use it to synchronize our React application with something outside of React. Once that idea becomes cleaner, use effect becomes much more easy to understand. Now let's understand what is a side effect. Because we talk about use effect, let's understand what a side effect usually means. So rendering should ideally be predictable. Given the same props and state, React should be able to determine what the UI should look like, but sometimes our application needs to interact with something outside of that rendering process. For example, we might call an API, we might start a timer, we might subscribe to a web socket, we might update the browser's document title, or we might interact with another browser API. So these are examples of side effects. So you can think of rendering as describing what the UI should look like, while effects are about synchronizing that UI with the outside world. So why do we need use effect? Why can't we simply perform these operations directly inside our component? So that question will come in your mind. The reason is that React components are expected to behave predictably during rendering. Rendering should primarily calculate the UI. If we start making API calls, setting timers, or modifying browser APIs directly during rendering, we can create unpredictable behavior. So use effect gives us a dedicated place for this synchronization logic. React first renders the UI, then the effect can run and synchronize something external with the current state of our application. So the mental model I want you to remember is render first, synchronize afterward. This separation makes our components easier to uh, understand. So let's move to another slide. Basic basic use effect syntax. So an effect receives a callback function, and that callback contains the synchronization logic. We can also optionally return another function. The return function is our cleanup function. Finally, we have the dependency array. The dependency arrays tell React which reactive values this effect depends on. So when you are looking at a use effect, I recommend asking three questions. What synchronization am I performing? What values does that synchronization depend on? And does that synchronization need cleanup? Those three questions will help us to understand more effects we encounter in real world application. So next thing is to understand when does use effect run. So the dependency array is extremely important here, and if we don't provide a dependency array, the effect runs after every render. If we provide an empty dependency array, the effects run after the initial amount. And if we provide dependencies such as count, React will run the effect initially and then run it again whenever count changes. So the dependency array is not simply a configuration option. It describes the relationship between our effect and the reactive values it uses. This is why dependency management is such an important part of writing reliable React application. Now let's move to dependency arrays. So look on this syntax. So imagine that we want to update the browser tab title whenever our counter changes, our effect read the count value. Therefore, count belongs in the dependency array. When the count changes, React knows that the synchronization may need to happen again. The effect runs and update the document title. This is a simple example, but it demonstrates an important principle. The dependency array should reflect the reactive values that the effect uses. Don't think of dependencies as value we add just to make React stop complaining. Think of them as declaring the inputs that our synchronization logic depends on. Now let's talk about some cleaner functions. So some effects create something that need to be stopped or removed later. A classic example is a timer. Suppose our effect starts a set interval. If we never clear that interval, the timer can continue running even when the components no longer needs it. The same idea applies to event listeners, subscriptions, WebSocket, connections, and other external resources. That's where the cleaner function comes in. We return a function from our effect. React can use the function to clean up the previous synchronization when it is no longer required. So a useful rule is if your effect starts something, ask yourself whether it also need to stop something. That's the mindset that help prevent memory leaks and duplicate work. Now let's talk about browser APIs. So we are going to synchronize our React state with the browser's document title. Our component has a count state. I will take you through code as well so you can understand it. I have created a one example here. So our component has a count state. Whenever the count changes, the effects update document title. So notice that document title isn't part of React state. It's a browser API. So that's exactly the kind of situation where an effect makes sense. React manages the application state. The effect synchronizes that state with something outside React. So again, we are seeing the same pattern. So React state changes, effect runs, external system is synchronized. So I have run. So you are seeing this is the title, count 8, count 9, count 10. And if you look on this code, so here I just have created a button, created a on click function, set count, just increasing the value, whatever the previous value is, it is just adding one on that. And this is a syntax for the use effect. I will explain each part of the code. So let's move to another slide. So it's about asynchronous data fetching. We have seen in a real application we frequently need to fetch information from a backend API. For example, imagine that the component displays a list of products, and when the component mounts, we can uh, start a request while the request is running. So you will see we set our loading state to true. You can see this use effect from line number 28. What is happening here? So when a request is running, we set our loading state to true. When the response arrives, we store the data in React state. And because the state change, React renders the products. So this gives us another important flow. Component renders, effect start request, request completes, state updates, UI re-renders. Notice that the API request itself isn't responsible for rendering the UI, it simply provides data. React state remains responsible for deciding what the UI should display. Now, uh, let's move to next slide, slide 10, loading errors and data states. So let's assume a production application can't assume that every request will succeed instantly. So we need to think about the different states the user can experience. First, we may be loading, then we may have a successful data, the request might fail, which gives us an error state, and we may also receive an empty response. These states should be represented explicitly in our application. This is an important front-end engineering principle. So, a professional application should make loading, success, error, and empty states intentional parts of the user experience. So, in our demo, we are going to model these state directly with the React state in this chapter. So, now next slide. So let's look at some common mistakes. Imagine that our effect depend on count, and inside that same effect we update count. What happens? The count changes. This causes the effect to run. The effect changes the count again. This causes the effect to run again, and then we can end up with an infinite updated loop. So this is why we should never add an effect simply because we need to update some state. Before writing an effect, ask, am I actually synchronizing with an external system? If the answer is no, there may be a simpler solution. So use effect is not for everything. So let's say we have first name and last name and we want to display full name. We could store full name in state and use an effect to update it whenever the first or last name changes, but that introduces unnecessary complexity. We can simply calculate cost and full name is equal to first name plus last name directly during rendering. Why? Because full name isn't an external synchronization, it's simply a value derived from existing state. If you can calculate something from existing props and state, prefer calculating it during render rather than creating an unnecessary effect. So this one principle can help us to avoid a lot of unnecessary React complexity and memory leaks. So now let's look on this. I will try to explain you. I have created a small product dashboard for this chapter. We are so we use here use state to manage our application state. We use effect to synchronize with external behavior. We simulate loading products from a backend. We show a loading state while the request is running. We display the products once the data arrives, and we also handle the possibility of an error or empty response. So it's not just a demonstration of syntax, we are thinking the individual concepts we have discussed and combining them into a realistic front-end system. So let's start with our state. I will show you the code. So line number 10, we have the product list, the loading state and the error state. We have our first effect which synchronizes the counter. Line number 23, which synchronizes the counter with the browser state, and our second effect handles the initial data loading process. So line number 28, you can see my second use effect. And finally, we return the cleanup function to make sure that the asynchronous operation doesn't update state after the component is no longer interested in the result. We'll take you to next slide, effect life cycle. So initially React renders the component, the effect then establishes its synchronization. If one of its dependencies change, React need to synchronize again. Before establishing the new synchronization, the previous one can be cleaned up. This is very useful mental model. Instead of thinking use effect means run the code after render, and this effect keep my component synchronized with an external system. The mental model leads to much better effect design. And the next thing, let's talk about some best practices in React. So first, use effect for synchronization with external system. Second, make sure your dependency array accurately represents the reactive values used by the effect. Third, clean up timers, subscription, event listeners, and other resources when necessary. Fourth, don't use an effect simply to calculate something that can be derived during rendering. And finally, keep your keep your effects focused. If one effect is responsible for five completely unrelated things, that's usually a sign that the logic could be separated. That the goal isn't to write more effects, the goal is to write intentional effects that are easy to understand and remain. So now let's recap this chapter 8. So, what we learned here, we started by understanding what side effects are and why React provides use effect. We learned how dependency array controls when an effect resynchronizes. We looked at cleanup function and why they are important for timers, subscriptions, and other external resources. We also saw how effects can work with browser APIs and asynchronous data fetching. And perhaps most important, we learned when not to use effect. If a value can simply be derived from existing states or props, we should generally calculate it during rendering instead. So if you remember only one sentence from this chapter, remember use effect is about synchronization, not about making React do something after every render. Once you understand that distinction, your React code becomes much easier to reason about. In the next chapter, we will continue building on these concepts and start looking at more reusable React patterns. Thanks for watching, and I will see you in next chapter.